Hi again. Cathodic Protection Network online training course, Module 1, page 2. This is probably the most important thing that you must relearn. A potential can only be measured in a laboratory, as the voltage that we measure must be compared to a standard potential that is agreed by convention, and it must be measured in closed circuit conditions. You must look at DIN 50918 and you must understand the implications of the setup which is shown. Therefore, the term pipe to soil potential is incorrect and should not be used, as this will confuse those who know what a potential really is. Such people as scientists in electrochemistry, electrical engineers, and electricians. They all know what a potential is, and they all know that a voltage is a potential difference, and that it is a voltage that we measure. Therefore, those who use the term pipe to soil potential must either not understand, or they must be deliberately intending to confuse. Any document or scientific paper that includes the term pipe to soil potential, or any abbreviation that means this, cannot be believed until the method of measurement is described in detail and the word voltage used instead of the word potential. I have gone to great details to explain electricity in a manner that allows you to make experiments to repeatedly observe the evidence about all of this. A potential is an electrical quality, and a voltage is a measurement between two potentials. Everything has an electrical potential. We can measure this potential by comparing it to another electrical potential with a meter. A multimeter displays a voltage because it sets zero at the energy level of the black terminal that we refer to as the negative pole of the meter. An oscilloscope does not set a zero. But can be adjusted to show the trace caused by the passage of electrons as they pass through the measuring circuit. There can be no such thing as zero potential, as that would be a void in the structure of the universe. And scientists, Gibbs free energy and all that, look it up, have defined that it is impossible to have zero energy. A voltage is always relational, and we must have a standard potential to relate every voltage to. As is seen in the 3 nails experiment that we'll be looking at later. The copper sulfate electrode cannot be used as the standard potential we need in cathodic protection field work. In a closed measuring circuit condition, it is possible to relate the reaction of copper and a saturated solution of copper sulfate to the reaction of hydrogen to platinum, as shown in DIN 50918. DCVG proves that the measurements that we make in cathodic protection fieldwork is between 2 ground contact electrodes that reflect the ground potential at the contact point. I have detailed instructions of the history of DCVG later in the course. This ground potential results from many electrical charges from an indefinable number of sources of energy. When we switch one of these sources of energy on and off, we can measure the effect of that switching, but not define the corrosion status of the pipeline or metallic structure that we are trying to audit.